Okay, so we are going to get started on Excel. So this is just going to be a primer on how to create an Excel uh, scatter plot, how to label the axes, how to do a best fit line, and add the equation. So here I've got a bunch of data. Okay, you can always adjust what this data looks like by allowing formatting the cells. So I'm going to highlight all of this data, right click, and go down to format cells. And you can right click and it always pops this up. I'm doing that a decent amount. Format the cells, and it gives you a bunch of options over what you want this to look like. Well, these numbers right here, there's at least 3 zeros before an actual digit. So it's really, we should have this in scientific notation. So scientific notation, and you can pick how many decimal places, and you can see what the sample is actually going to look like, and that's what we're going to do. So it's a little bit easier to read. It gives you some idea of what these numbers actually look like, but this is our scientific notation. So if we want to highlight data and graph it, okay, so first of all, I want to just select all the data. If it's right next to each other, you can just hit highlight it all. But otherwise, I'm going to click. If it's not next to each other, I'm going to select one of the columns. I'm going to hold down the control, and I'm going to select another set of data. So if this set of data, for example, we're over a couple cells, okay. Oh, if this set of data, let's try it again. We're over a couple of cells. Highlight this, hold down control, and highlight that. And we can now insert, and then I'm going to go to scatter plot. So charts, and I'm going to choose a scatter plot, and it's going to show you what it looks like. Okay, so here we go. We've got this stuff all sorted. I'm going to click it. There we go. We've got our data plotted. You can see which stuff is where. Well, we're going to look at the axes, and we can see 0.8 down to 0.1. That's the absorbance on this axis, and concentration, or the FeSEN2 plus, is on this axis. So this is probably how you would plot it, but because this is practice, I'm going to show you how we can switch the data. And so if the axes are wrong, you can either go back and try to make the chart by highlighting the absorbance first and then the iron, or you can just click on the data once, and then I'm going to right click all the data selected. Now I'm going to right click, and now I'm going to go to select data. So I can tell right now I can tell my current series is the one here. Okay, so I can edit this current series, and I can basically say, no, you've got it in the wrong axes. Let me correct which axes things go on. So in this case, I'm going to move the absorbance to the x-axis. So I'm going to hit edit, and I can delete all of this, or I can just hit this little button here. So if I click this, I can just delete all this. And now I can select the data. So this is the x-axis. So I'm going to highlight all of this. That is now on the x-axis. Notice the axes are the same. Okay, and now I want to change the y values. So I'm going to click on that little button, and I'm going to highlight this. And so now I'm going to put all of that on the y-axis. Did it do it? Yeah, it did. There we go. So we've switched the axes. Okay, and that's totally reasonable to do. You might run into that. All right, next up, we need to change the chart title. I always want the chart title to be y as a function of x. In this one, it's not really going to make sense because it shouldn't. But in most cases, this is the most sense you can make out of your data. Concentration, in this case, it's concentration as a function of absorbance. Really should be the other way around, but we reverse the data, but you get it. Y as a function of x is how you should look at this. Okay, so that should be your title. Now I'm going to add some chart elements. So I can hit insert. I'm sorry. So I can at home. Sorry. So what we want to do is select the data. Okay, or select the chart rather, and you can add. So if I double click this chart, okay, it gives you a bunch of options. By the way, you can also adjust the axes. So if I wanted to say I don't need 0 here, you can double click on this and focus on just this axis, and you can adjust those. So these are all these axes options, all these axes options over here that allow you to adjust the showing the margin and a bunch of different other things. Anyway, back to this. So we're going to add chart element. I'm going to add axes titles. I'm going to add the primary, and I'm also going, actually, I'm just going to add the primary, and you could do the horizontal as well. So I'm going to change this. I know that this concentration, And the unit is going to be in molarity, capital M. There we go. So you can add the other axes as well. So that's it. That's how we do it. And now the last thing is adding a trend line. So I can click on the data. So it selects all the data and it shows it, because if I have another set of points, I could do the same. Again, I'm going to right click and I'm simply going to go to add trend line, and it's going to give me this whole list. Okay. So I'm going to display the equation. I'm also going to display the R squared. There it is. Okay, I'm just going to drag it up there so you can see it better. And that's it. That's our trend line. You can, if I set the intercept, it forces it through 0. Okay, it makes sure that it goes through 0, or you can set whatever intercept you're looking for. But you notice that when I do that, the data, funny enough, the data actually improves when you force it through 0. No, it gets worse. We're good. So here we go. Here's the data. And you can see it's a really good fit. The R squared you're looking for is 1, is ideal. And we're going to talk about that in just one moment. But an R squared of 0.99 is really good data. 0.98, good data. 0.95, not that great. So less than like 0.95, you're getting a little bit suspect. You can also, you might have a logarithmic curve. This is clearly not a logarithmic, or an exponential, not a good fit. So what we're doing is we're looking at that R squared value as we change these different types of options, right? But the important one is the linear. We're pretty much always going to convert it to a linear. So logarithmic, not a good fit. Exponential, not a good fit. Linear, absolutely, it's a great fit. So this seems like it. Okay. And I was going to show a 2-point graph. A 2-point graph is always going to give you, there's only 2 points. It is always going to give you an R squared of 1, right? So just keep that in mind. The R squared means nothing when there's only 2 points. So I don't need to go into that, but that's how you create a graph and do a best fit line. All right.